All right, so we want to do the net torque around this point here. So this is our axis of rotation over here, right? So there are three forces. You want to draw an R vector to every one of those forces, right? Like, let me see. My R vector from here to here. This is 1 meter. So let's do the torque for this guy. Okay, so first we also need to establish the direction. So we say counterclockwise is positive, clockwise is negative direction. These are all going to be clockwise torques, so it doesn't really matter, but it just as a habit. So this is 1 meter. Now we don't care about, notice that the force and the R vector are not perpendicular to each other. So we have to decompose one of them. In this case, I think this is like a 3, 4, 5 triangle. So I think the idea is you can write a triangle like this. This is 100 over here, but I only care about the component perpendicular to the R vector right here, right? So if this is 100, this is 60, and this is 80. So the torque for this guy is going to be, one, it's negative, because I said clockwise is negative, and then the R is 1, and then the component perpendicular to that R is 60. So that's negative 60 for that one right there. Okay, so now let's do the next one, right? Let's do this R vector here. So now we're going to draw R vector from here to this force. This is already, and this R is 1.75. That's the distance. And so they're already perpendicular, so you just multiply them. So it's going to be negative 1.75 times 70, which is negative 122.5. Okay, so that handles that one. And then now let's do this last vector over here. As you draw this R vector, that is 2 meters. And notice that this is, I got to decompose this one, 50 newtons. I got to decompose into the X and Y components. If this is 50 and the hypotenuse is 13, oh, this is really annoying. I want this side here, which is 12/13 times 50, right? Because there's a little bit of, just think of it as like a similar geometry problem. Like this is 13, 12, and 5. And then I'm trying to convert it into this rectangle here, which is, or this triangle here where this is 50. Right? And then I want this long side here. I want this side that's perpendicular to the R. So I want this guy right here. So in terms of ratio, you say 12, this to this is the same as, or maybe do X to 12 as 50 is to 30. 50 is to 13, sorry. So X is then 50 over 30 times 12, right? So that is going to be 12 divided by 13 times 50 is going to be 46.15. And so the torque is going to be that 2 meters times that 46.15, and that's going to be negative. And I get negative 92.3, right? So then we just add these all up. Negative 60 plus negative 122.5 plus negative 92.3. Minus 60, and I get negative 274.8. You can make that plus or minus, and this is Newton meters is the units. Plus or minus, I made a minus because I said clockwise was negative, but if you made clockwise positive, then a positive number is fine.